Welcome. What we're going to do in this video is to find the missing angles of a triangle where we are given the three sides. Now, in a situation when you know three sides of the triangle and you want to find the angles, you also want to make sure that it is a triangle that can occur. So with the three sides, it's always important to check the smaller sides sum. So 30 plus 36 is 66. And make sure that number is greater than the larger side. And 66 is greater than 51, so I do have a triangle that can be made from these sides. Now to find what we can do in order to get our angles, we want to see what information we have. And since we know the three sides, we have the side, side, side case. And recall that the side, side, side case is a case where we use the law of cosines. So with this, with the law of cosines, finding our first angle, we just want to focus on one of the angles and then work from there. And let's first find, let's say, our angle gamma. So we look at our angle gamma, and remember the side across from gamma is C, the side across from beta is B, and the side across from alpha is A. So the law of sines that we want to use if we are looking at finding gamma first is C squared, the side opposite the angle we're searching for, is equal to A squared plus B squared minus 2AB cosine gamma. Now we'll put in the values that we know. So C is 30, so I have 30 squared is equal to, A is 51, so 51 squared plus 36 squared for B squared minus 2 times 51 times 36 times the cosine of gamma. And what we can do is solve for the cosine of gamma. So I'm going to add the 2 times 51 times 36 cosine gamma to both sides and subtract the 30 squared from both sides. And that's just to make sure that I'm careful with the signs. And then divide both sides by 2 times 51 times 36. So cosine gamma is equal to 51 squared plus 36 squared minus 30 squared all over 2 times 51 times 36. And then to find gamma itself, take the inverse cosine of both sides. And make sure you check to see that your calculator is in degree mode. And when you go through and calculate that, you will get that your value for gamma is approximately 35.29614, and that's degrees. So as I report it, we'll go to the nearest degree, so 35 degrees. But I wanted to write it out that far so that when I use it in a future calculation, I don't propagate error. So I want to use a value that is several decimal places beyond what I want to ultimately approximate to, so that the error doesn't get propagated. Now from here, we could actually use the law of cosines to do that same process around. But if when we look at this, we want to use the law of sines, as long as we go for the smaller of the two angles that are left first, then we will be able to solve our triangle. So how do I know which one's the smaller of the two angles? Well, the smaller of the two angles is across from the smaller side. So the angles that are left are alpha, and the side across from alpha is 51, and beta. the side across from beta is 36. So even if I wouldn't have drawn the triangle accurately, since 51 is bigger than 36, my alpha is a bigger angle than beta is. So beta is the smaller, that's the one that I would want to look at finding next. And if I do that evaluation, I can go ahead and use the law of sines. So by the law of sines, I have that pair of information, C and gamma. So 30 is to the sine of 35.29641 degrees as 36 is to the sine of beta. And when I solve this, I will multiply both sides by sine beta and sine of 35.29641 degrees. So I have 30 sine beta is equal to, was approximately equal to 36 times the sine of 35.29641 degrees. Divide both sides by 30 and take the inverse sine. So I have beta is approximately equal to the inverse sine of 36 sine of 35.29641 degrees divided by 30, and we get that beta is approximately equal to 43.897 degrees. So we're going to have it approximately equal to 44 degrees, rounded to the nearest degree. And then alpha can be found because we know that the three angles of a triangle add up to 180 degrees. So my alpha is equal to 180 degrees minus the 35 degrees minus the 44 degrees, and I get alpha is approximately equal to, and I have the value of 101 degrees. And that's how you can find the three angles of a triangle when you know the three sides.